Hello, everyone, and welcome to this chapter. In this chapter, we're going to be talking about Flutter hooks. Now, Flutter hooks themselves are not really means of state management as such. You may be used to RiverPod, for instance, or inherited widget, inherited model, or you may be used to blocking Flutter. Flutter hooks, they're kind of different in that they're not like this traditional means of doing state management. However, I've included Flutter hooks as a separate chapter simply because, and when we then later in this course go and talk about, for instance, RiverPod, you will notice that there's lots and lots of things that are connected from Flutter hooks in RiverPod. So if you're trying to learn RiverPod as a state management, you kind of need to know about Flutter hooks. And Flutter hooks, and it's kind of its own library or package. And that is the reason I've made a separate chapter about this. Before going into RiverPod, we need to understand what Flutter hooks are and why they're useful. So Flutter hooks themselves are very, very similar to React hooks. And if you're not a React native developer, for instance, or if you haven't programmed with React before, you probably are not familiar with hooks. So I suggest that you go ahead and read the documentation that I provided at the bottom of the screen, which is, it's not really a documentation as such. It's mainly a proposal from React team for moving the React code base mainly to use hooks. And the word hooks come from there. So the reason we have Flutter hooks is simply because there was the idea of React hooks, and then it made sense to kind of have the same thing for Flutter as well, for the reasons that I'm going to explain to you. But it would be really good if you could just pause this video and read the link that I provided at the bottom of the screen. It should take about 10 to 15 minutes to read, but it will give you a good idea of what hooks are. Although I'll do my best to explain what hooks are also in this chapter, I think it's also really good for you to go ahead and read that documentation yourself. So hooks in their core are like a way to reuse code without having to write boilerplate code over and over again. So let's say, for instance, that you have a text editing controller. If you're a Flutter developer, for instance, you are already probably familiar with how to set up a text editing controller. You go and define, for instance, a late final variable. You initialize that variable in your init state, for instance, and then you dispose of your text editing controller in the dispose function of your StatefulWidget. However, this pattern is something that you will have to do over and over again if you have text editing controllers. So let's say you have 4 or 5 of them in one screen. Then you have to go and do the same thing 4 or 5 times. And then if you have another screen with text editing controllers, you have to repeat the same pattern. And the reason that that is the case is the resource management of text editing controller in Flutter is tightly coupled with your StatefulWidget, in that it needs to be initialized and it needs to be disposed of. So there's a certain pattern required by text editing controller for you to follow. And this adds into the complexity of reusable code, in that text editing controller setup and disposal is not as reused as you would want it to be. And Flutter hooks really try to address that issue, as you'll soon see. So in Dart, just like many other object-oriented programming languages, every class can have at most one superclass. So this superclass kind of dictates, just one superclass dictates the lifetime of your classes. So if you have code that you want to reuse across multiple classes, the typical programmer would go ahead and create a superclass and then would subclass that class and be able to reuse that code. Then will be very easy in your subclasses. However, that's not really as flexible as you want it to be. Sometimes you have a class that doesn't really care about all the code that is written in a superclass. It only wants a certain function or only wants a certain functionality. And for that, in Dart, there's something called mixin. And mixins also are I mean, they're quite good approach and attempt at fixing some of these problems in that they allow reusability without having to subclass things. However, mixins have also their own issues, as you'll soon see. So, hooks in Flutter and Flutter hooks as a package itself gives you a lot of flexibility in terms of being able to reuse pieces of your code, as I've mentioned before. And there is a little limitation in how hooks are used in Flutter, as you'll soon see. Flutter hooks and all the various hooks that are created, which you can reuse, as you'll soon see, is they need to be used in the build function of your widgets. And we're not going to use stateless widget or stateful widget in this chapter. We're mainly going to use a new widget, which comes with Flutter hooks, which is called a hook widget. And unsurprisingly, HookWidget is able to then manage the lifetime of your various hooks. So there are some rules to follow when it comes to hooks. There are some do's and don'ts, which I'm not going to go through the entire chapter. Otherwise, it would be just do's and don'ts. So I suggest that you go ahead and read this documentation that is provided at the bottom of the screen. And in this chapter, we're going to write 8 separate examples that demonstrates the usage of Flutter hooks. So I'm going to provide you with lots of examples, but also it's good for you to read the documentation on stuff to do and don't. So one thing that's important to understand is hooks. When you, for instance, retrieve a stream hook or a StreamController hook, or when you're using a use effect hook, these are all controlled by their index. And because inside a build function of your widget, you can have various hooks. So you can have hook 1, hook 2, hook 3. And these are all addressed using their index. If anything happens to that index, for instance, between rebuilds, because we have hot reload and hot restart in Flutter, mainly for hot reload, this is a concern. If anything happens to the index, like there's a change in the index of these Flutter hooks, for instance, you remove a hook, all the hooks that come after that index, so let's say you had index 1 hook, index 2 hook, 3, 4, 5, so you have 5 hooks, and you remove the 3rd hook, meaning that now you have 1, 2, 3, and you remove this one, then hook 4 and 5 will be rebuilt, because 1 and 2 stayed at the same place that they were. 3 was moved, meaning that 4 comes to the previous place that 3 occupied, meaning that the index of the 4th hook is all of a sudden the 3rd hook. So Flutter hooks internally uses this mechanism for index in order to rebuild its hooks and understand what has changed from the previous state. And this is simply a mechanism put into place in order to be able to handle hot reload in Flutter, because a lot of other programming languages and SDKs or frameworks don't have this concept of hot reload. But since Flutter does, it's a mechanism for hooks in order to understand what has changed from the previous state to the new state. But don't worry about it. We'll talk about that soon. So it's just a lot of theory for now. So what we're going to do in this chapter is going to create a project. So we're not going to create multiple projects. So just one project. Throughout this chapter, we're just going to change that. Okay. So we're just going to add some stuff to it, remove some stuff, and then we're going to create 8 examples out of that project. So I'm going to bring here the terminal. So let's go ahead in here, and I'm going to change some stuff on the screen so you see my screen better. Okay. I'm going to say Flutter create testing Flutter hooks. I'm going to append underscore course to it as well, simply because I have already this folder created, because I have all the examples here on my 3rd screen. And I'd like to add also the organization. So SE, Pixology. Okay. So this is going to go ahead and create our project for us. Great. So that's done. And now that we've taken care of that and created our project, let's go ahead and open Visual Studio Code in there. So I'm going to say cd Flutter hooks course. think we created a testing. Okay, Flutter Hooks course. And then I'm going to open Visual Studio Code right there. We don't need the terminal because there is a built-in terminal here in Visual Studio Code. And I'm going to make the size quite big here so we see the screen a little bit better. Okay. Great stuff. So what we're going to do is to create a simple scaffold right now. I have a code snippet, which I've created a YouTube video tutorial for how I have this snippet. But all it does is really, it allows me to write FSA, which is Flutter Scaffold Application or something like that. And then it just creates the main homepage for me. So if we go now to our project's main Dart file, I can just type FSA in here and it will just create the scaffold. So this is nothing magical, to be honest with you. It's simply, it puts the run app and the material app inside the main function instead of having the material app separately. And it also creates a simple home page in here with a basic scaffold with an app bar and no body. So this is really all we have to do to create this. And you can go ahead and do the same thing if you're watching this video at home or wherever you're doing this from. So what we need to do is to go ahead and add now Flutter Hooks as a dependency. As mentioned, Flutter Hooks is a third-party package freely available on pubdev, and you need to add it to your project as a dependency, of course, in order to be able to use it. So let's go ahead in terminal, and I'm just going to say Flutter pub add Flutter Hooks, just like that. And this is going to go and grab that dependency for us and bring it into the project. And as you can see in here, this is the output. Changed one dependency, and it brought with itself everything that it had to in order to have Flutter Hooks in our project. So let's have a look now and adding that Flutter Hooks as an import as well. So we're going to say package Flutter Hooks, okay, just like that. So now we have Flutter Hooks added to our project. So what we're going to do in this first example is just to go easy and create very simple application with Flutter Hooks so that you get the idea of how Flutter Hooks actually work. So what we're going to do is to create a simple stream that ticks or sends a value every second. And this stream's ticks that come every second are then going to allow us to update the title of our homepage. So every second, we're just going to update the title of our homepage and display the current time as the title of the homepage, okay? So what we're going to do first is to create our stream. And remember, this is just going to be a simple periodic stream. So what this stream is going to achieve is going to tick once a second and it's going to return the current date to us. So let's go ahead and write the stream right now. So I'm going to say stream of string. And let's just say get time, okay, as you can see at the bottom of the screen. And then I'm going to say this is a periodic stream like this, and the period is a constant duration of seconds, just 1 second. And we ignore the incoming value. And whenever there's a tick in the stream, we're going to say date time now, like this, and then ISO string, like this. So this is going to achieve that goal for us. So it's going to create a stream of string that returns the ISO 8601 string representation of the current date to us every second. Okay. So what we need to do is to consume this stream. As you know, you cannot have a stream builder inside your app bar because app bar is kind of like a special class. So if we go to app bar's code, you can see it is actually a preferred size widget. It's not just like a normal stateless or stateful widget. So we're not going to go ahead and say, okay, now that we have the stream, let's just replace this app bar with for instance, a stream builder. However, what we're going to do is to start using something called a hook widget. Okay, so let's go ahead and say in here we have a hook widget. This hook widget, it's kind of like the home page of all your hooks. If you want to use Flutter Hooks, if you want to use any of the hooks that are shipped inside Flutter Hooks, then you need to make sure that your widget that is consuming those hooks is of type hook widget. Now, hook widget, and so it is actually a stateless widget. So if you go in here, you can see that a hook widget is an abstract class. Hook widgets extends stateless widget. So it is kind of like magical the way hooks actually work in that a hook widget, though stateless, can contain state. So it's kind of like it's a strange thing to think about, but it is purely magical, to be honest with you. It's just the implementation makes it so that you don't even have to create a stateful widget because you're not holding onto any state yourself. So remember, just whenever you're using any hooks, you need to make sure that the widget consuming those hooks is of type hook widget. And in the chapters that will hopefully follow after this chapter, when we talk, for instance, about Riverpod relies quite a lot on Flutter hooks because it's Riverpod and Flutter hooks are written by the same person, Remy. And Remy's he's reusing the code that he's written for Flutter hooks also a lot in Riverpod. So Riverpod has this dependency on Flutter hooks. So what you're learning in this chapter is going to be very important when we go to a chapter talking about Riverpod. So I'm actually going to work on that chapter, but kind of waiting for Riverpod 2 to be available. But I'm just going off on a tangent right now. So what we're going to do in here is to use our first hook. And this hook is called use stream. You see, one of the do's of hooks is that your hooks should always start with the word use. And this is following the same path that React hooks have gone through. So all your hooks, they're functions, and they start with the word use. So if you go into the build function here in your hook widget and then type use, you can see there are quite a lot of hooks that you can start using. Use value notifier, you have use previous, reuse reducer, which we're actually going to use and have a demo of that in, I think it's the 7th example in this chapter that we're going to create using use reducer. But all your hooks start with the word use. Just keep that in mind, okay? So what we're going to do in here is just to say final. We want to get the date time. So we're going to say date time is use stream. Okay. And you can see that the first parameter that you pass to use the stream is the stream itself. So let's go ahead and say gets time. Okay. So you see now this is very interesting. I mean, if you haven't used with hooks before, which I think almost everyone watching this chapter probably hasn't really used the hooks before, otherwise you wouldn't be watching this chapter, maybe is that this use stream itself returns an async snapshot to you. You can see it's an async snapshot of string. So it's like, not only is it kicking off the process of listening to the stream, but it's also giving you the return data of that stream. So all this stuff that you would otherwise do with a stream builder, you're doing simply with one hook, use stream. Okay. So you can also go, I mean, I do this all the time because I'm curious about these things, how they work. I always go into their source code and see how they work. You can see it's using a function called use, and in there's actually a hook, a stream hook. So I suggest, I'm not going to do it here, but I really suggest you go and read the code for all these hooks and just get kind of like a general idea how they work, okay? So what we're going to do is to actually consume this date and time right now. So let's go in here, remove this const, okay? And what we're going to do in here, we're just going to say date time, data, otherwise homepage. Because remember, data is optional because there's a parameter in async snapshot called has data. We're not going to look at that. We're just going to optionally read the data. If there is no data available, we're just going to say homepage, okay? So right here, I'm going to say select device and run it on my iPhone simulator, and then run the application. Let's see if I can bring the simulator up as well. So here we have the simulator. I'm going to bring it here to the screen, and soon we're going to see the results on the screen as well. So while this is happening, I want you to have a look at the source code and see that what we are creating here is actually a stateful application, in that it has the current, it's showing the current date and time, something that you would otherwise do with a stateful widget. But here you're doing it you're doing it with a hook widget. And as you can see, here's the result. So you can see the date and time being printed to the screen. So this was just like a very simple example of how this actually works. So let's go ahead and have a look at the source code for this use stream. So here, use stream, you can see it's using a function called use, and you can go and have a look at this function. And I suggest you read the documentation about that. So if you're creating your own hooks as well, which you probably want to do, the more comfortable you get with Flutter hooks, you may also be consuming this use function. I'm trying really hard not to say use the use function. So consuming maybe is the best word. So I really suggest that you actually have a look at these and how you can create your own hooks as well. So this could be a little bit too much to handle right now if you're used to stateful widgets and stateless widget, and that stateful has state but stateless doesn't. I understand that, but this is kind of like the point of hooks: reusability. You don't have to you don't have to repeat yourself when you're using these hooks. You don't have to have a stream builder. You don't have to consume a stream in the traditional way anymore. You can just use a hook widget and then start using your hooks. Okay, so this could be a little bit too much to begin with, but you will get used to it hopefully by the end of this chapter. So what we're going to do is we're going to go through, I mean, I've said we're going to go now through every single one of them, but I don't think I'm going to go through every single one of them. We're going to go through most of them. And also I've picked like the most useful hooks. There's so many hooks available, and you can actually bring up your web browser, for instance. So if I bring up Safari here, let's just go and say Flutter hooks. So here's the website for Flutter hooks. So there's so many hooks available. You can see the documentation at the bottom. There are lots and lots of hooks available, as you can see here. Use effect, use state, use memoized, and there are tons of them. But I think we're going to explore more than half of these in this chapter. So it's going to be exciting. Now that we've gotten to this point, let's go ahead and commit our code. So I'm going to go to terminal in here. I'm just going to say git init, and then we're going to say git add all and git commit step 1. Okay. Now we've committed our code for step 1, and then we're going to go to the next example. So I'm also gonna, I have all the code also for all like the examples I'm going to go through in this chapter to my left-hand side. So I'm basically checking out that code as well to make sure I'm not missing anything while explaining things to you. So what we're going to do in this example is going to use 2 new hooks. And they're going to be 2 hooks that are called use state and use TextEditingController. So what we're going to do, it's going to be actually very simple. It's a text field on the screen. And every time you type something in this text field, we're going to get that value and maybe print it somewhere, or maybe just display it on the app bar or whatever. So if you're like used to doing it the traditional way with Flutter, you'd probably say, oh, well, it's a text field. I have a text editing controller, so I have to have a stateful widget. And then I have to have a text editing controller, init it, dispose of it, assign it as a controller to my text field, and then maybe have a listener. Every time that listener function gets called, I'm going to update something. So that's like the traditional way of doing it. But we're not going to go and do it that way. We're going to use Flutter hooks, and it's going to be so compact. I think you're going to fall in love with Flutter hooks after this example, hopefully. So what we're going to do is going to clean up the code in here. As you can see, let's just have the app bar, and we're going to remove the stream from here like this. And in here, we're just going to say home page, just like that. Constant home page, okay? And the rest we don't need. So let's have the home page, and I'm going to bring up the simulator, and it's going to look like this. So no special logic in your home page, okay? So what we're going to do in here is to first of all go and create a text editing controller. Now there is a hook available for that, and it's called use text editing controller. And this creates a text editing controller for you, and it takes care of the initialization and disposal of it for you. It is, I mean, it's purely magical, because you'd be like, oh, well, how is it taking care of that? And the response to that is that HookWidget itself, this class, it knows when you inside this hook, when you create new hooks. So when you use and consume a new hook inside the HookWidget's build function, that hook will be registered with your current instance of HookWidget using its index and its class. And then HookWidget is then responsible for disposing of that for you. So it's basically holding on onto these hooks for you. You can see in here it says a HookWidget hooks. So it's it's really just magical in my eyes. So let's go ahead and then create our text editing controller. So we're just going to say let controller. Sorry, let's. I went to Swift. So let's just say a text editing, or just call it controller, and we're going to say use text editing controller, just like that. So this is probably like a huge contrast to what you're used to, how you how to create text editing controllers, but this is how you would do it in the Flutter Hooks way. As you can see, this controller is now a text editing controller whose lifetime is completely managed for you. So, okay. So let's quickly have a look at the source code for use text editing controller. In here, you can see in here, it says text editing controller hook creator, which comes in here. And you can see it is a callable function, and it's inside it using text editing controller hook, which itself is created this way, as you can see. So I highly suggest actually you go ahead and have a look at this class and look at relevant code for it as well to get a better understanding how it's working. So now that we have the controller, we also need to hold on to some sort of a state, the current text. So we need to hold on to the current text so that whenever there is changes in this controller, we want to update that text. So how do you create state? How do you create a variable that changes over time inside a hook widget? Because remember, hook widget is a stateless widget. So what we're going to do in here is use a new hook called use state. And let's go in here and just say final text, oops, is use state and just an empty string. So you can now see text is a value notifier. So all of a sudden, use state is returning to you. Actually, we can have a look at the use state source code. It returns a value notifier for you. So it's really magical because now every time you change the value of this text, anyone listening to this text is going to get notified. So now we've created two new hooks. Use text editing controller to create the text editing controller itself, and also a text state, which is a value notifier. But we haven't hooked these two together. Like changing the text in the controller is not at the moment updating the text. So how do we do that? And for that, we're going to use something called a use effect. And use effect, as its name indicates, it's kind of like it's a side effect of something else. So use effect is going to allow you to do something while something is happening. Okay. So we're going to go ahead and actually use our use effect for this example. For those of you who are familiar with Rx, use effect is kind of like how you would create a completable or observable or a single, in that you go and say completable dot create, and then you get an observer and you return a disposable. So it kind of like gives you the ability to create something out of something else and then manage the resources. So that's what use effect does. Okay. So let's go ahead. I'm going to show you this use effect, how it's used, and then hopefully you'll understand what I mean in here. So let's go ahead and use this use effect function. As you can see, use effect is it needs to return something called dispose, optional dispose, okay? And it is a function, and it's called effect. And then the second parameter to this is keys. Okay, I'll tell you what this actually means. I think it's a little bit difficult to explain all of this without actually showing the code. So this is the simplest form of writing use effect. Just a void callback that doesn't return anything. So let's go ahead for now and just say return null, so we get rid of that little warning in there. So what you need to do in here is to actually write the code that consumes that controller. Okay, so how do we do that? How do we actually start listening to changes inside this controller? Well, this controller has an add listener, okay? And in here, we're just gonna say add listener text in here, dot value is controller dot text, okay? So what we did is we just added a listener to our controller, and whenever the controller's text changes, we're also updating this value notifier's text as well, or its value in this case, which is a string, okay? And remember, when you set the value of a value notifier internally, value notifier is a change notifier, and it's gonna call, I think there's a function called notify listeners. So you can have a look at this setter inside value notifier, And you can see what it does. It makes sure it's not the same value as before, and it calls notify listeners at the end. So I've talked about these actually in the previous chapters. We talked about value notifiers and change notifiers quite a lot. So please go ahead and watch those chapters, which are going to help you with upcoming chapters as well. So that's that part at the moment, okay? And what we need to do in here is, you see, hooks. At the moment, we have 3 hooks in this hook widget. In the build function, we have this use text editing controller, we have use state, and also use effect. However, we don't want this use effect function to be called every time we do a hot reload. So because whenever we do a hot reload, this build function is going to be called again, and then a controller is going to be created, the text is going to be created. But remember, these hooks are not actually going to be recreated, because they have a state, they have like their keys, and the hook widget is holding on to them. So I mentioned this when we talked about indexes. They have their own index, and when you do a hot reload, then Flutter Hooks is going to say, the first hook is a text editing controller. It's the same as it was before. I'm not going to rebuild this controller. So these two are holding on to their own instances. However, this use effect has nothing to identify it. It's just a void callback, right? So what's going to happen is that this use effect function is going to be called every time you do a hot reload, and we don't want that. So we need to give some sort of a key to this use effect to say, as long as this key is the same, don't call this effect again. And that's why we're going to go to this second parameter in here and identify what makes this effect unique. So let's go ahead and say we have our controller as the key in here. Okay, so this is our code right now. So what we're going to do is to go ahead inside this scaffold. At the moment, it has an app bar, but what we're going to do is to create a column in here. So let's go for the body, create a column with children like this. And then what we're going to do is to create a text field, so like this. And what we're going to do in this text field, all we're going to do is to say controller is our text editing controller from before. Okay. And then for the text is what we're going to say in here is to say new typed, and we're going to just bring in that value here, text.value. Remember, this is a value notifier, and it has a value in it. So every time you type something in the text editing controller, this effect is going to be handling that for you. It's going to set the text, it's going to set the value of that text state, and it's just going to basically work, as you'll soon see. So let's save this file now, and let's go and have a look at a demo. So at the moment, you can see the app is running. There's a home page on the app bar and a text field in here. And then you have the text widget in here. So we haven't typed anything, but I can just say hello world. And you can see that this text is being updated. And you see, we haven't done any stateful stuff in here. Like really, there's nothing that is making this widget stateful. And that's the beauty of Flutter Hooks. They kind of allow you to reuse all the functionality of stateful widgets without you actually having to create a stateful widget, okay? So hopefully you're now getting a hang of Flutter Hooks. To me, they're absolutely beautiful. Like I can't think of actually writing Flutter applications without Flutter Hooks these days. So and the more we go through this chapter, I hope the more you'll understand how Flutter Hooks actually work. Okay, so let's go ahead and commit our code and tag it as well. I actually don't know if we tagged our code in the previous section, so let's have a look. Git tag. We unfortunately haven't tagged our code, but that's okay. I'm gonna stash our code, and I'm gonna have a look at the logs and then tag it however it was before, and then git stash up, and then git add all, and then git commit step 2. Okay, and then we're gonna just tag this one as well as step 2, like that. Okay, that's perfect. That's really all we have to do for this example. And in this next example, what we're going to do is to load an image into memory using a future, but we're not actually going to use a future builder for this, as you'll soon see. So this is going to be one of the hooks that actually can consume a future, as you'll witness soon. So what we need also is to avoid having an empty container while our image is loading. Now, let me explain how this actually works. As you're probably used to this, as you're creating a future and waiting for that future to happen, you kind of want to display something to the user. So you want to, for instance, have some sort of a container or some sort of a sized box. And this is like a typical thing that a Flutter developer would do in saying that, okay, am I still waiting for this future? Is this future finished? If not, then you have to display something to the user, maybe a loading indicator or something. And a lot of developers just go ahead and say, oh, well, if there's no data, just you return an empty container. And if there's data, return the image. But what we're going to do in this section is to go ahead and make it a little bit more intelligent, saying that, well, if there's data, then here's the image. If not, there's nothing. Okay, so we're just going to focus on this nothingness for this example as well. And for that, we need an iterable extension that can get rid of any null values. So while we're waiting for the image to be downloaded, the image container is going to be null. And then in the result, we're going to remove that null. This operation in many other programming languages is called compact map. And compact map isn't really available in Dart yet. And the reason you would need it is just to avoid having empty containers, really. So what we're going to do is to go ahead and write this functionality, which is called for us compact map. And I'll show you how to do that. So it's actually easy to implement it. It just requires some thinking, to be honest with you. So let's go ahead and write this functionality right now. So we're just going to call it compact map. Okay, so extension, compact map. It returns some sort of a t, some value, we don't know. And this extension is actually on iterable, whose elements are optional values of t. Okay, so an optional widget, for instance. So this could be a little bit difficult to grasp at first, but the more you think about it, the more you will see how it actually works. Okay, but don't worry, I'll show you how it works. So what we're going to do is to say this is actually iterable that returns t, not optional t anymore. So it gets rid of all the nulls in this iterable. And we call it compact map. Okay, and we say the values that actually go into this compact map are, for instance, of type E, as in element. And what we're going to do is to have some sort of an optional function in here. So let me put square brackets in here and a square bracket in here. Okay, and this function, what we're going to do in here in this function compact map, we're going to accept a function. What's going to happen in here is that our compact map function is going to call this function for every element inside this iterable. And the result of this function is going to be an optional value of E. So like this. So this function is able to return an optional value of type E. Okay. So what we're going to say is that it is a function, and its parameter that is passed to it is actually the value of this iterable. Okay. And we're just going to say this function is actually itself optional. You don't have to pass this function to us, and we're going to call it transform. Okay. And what this function is really going to do is use the map functionality of iterable already. So there is a, oops, if I can spell. So we're going to say map, and I'm going to go to the next line to make this a little bit cleaner. And what we're going to do in here is to say, okay, map actually requires a function, which is our transform here. However, transform is optional. So what we're going to do is to say if transform is null, then we take the element and just return the element. So that's like the default functionality. Okay. So that's our map in here. The argument object function can be assigned to. Okay. I think that's fine for now. And then what we're going to do in here, we're going to use the where statement, as you can see in here. And we're going to then say this element, which is E, as long as E is not null. Okay. And then we're going to just say cast, just like that. So, I mean, it looks a little bit strange, but I will just explain it one more time to you. So let me just put some commas to make it look a little bit nicer. So what is happening in here is like, perhaps it's actually good to have a look at an example. Okay. So let's go in here and write a function in here called tested, for instance, which I usually do. Okay. Now let's say you have a list of numbers, 1, 2, but one of those numbers is null, and then 3. Okay. So final values. Now, if you look at the data type of values, what is it? Is a list of optional integer, because the first two are numbers, but the third one, unfortunately, is null. If you remove that null, values is what? Is a list of integer. However, what do you do in this case if you want to remove that null? That's exactly what compact map does for us. So let's just say final non-null values is values.compactMap. So, and now you can see the result of this is an iterable integer. So it actually got rid of the null value for us. So this is how compact map actually works. And the beauty to that is that you can actually create your own function in here to say, okay, I take the element and I have the ability to either return a new value. For instance, in here, you can just say, I ignore the element and I just return hello. The result is just going to be an iterable string instead. Oh, iterable int, it thinks, but it's really not. So, but you can in here actually convert this value to something else if you want to. So actually, right, it can't be a string. So it has to be the integer, because that's how we've written the function element in here, as I can see, okay? So in here, you could just say if e, for instance, is more than 10, then return null, otherwise return e. So in here, let's see if you can actually do that function in here. We just say if e more than 10, return e, else return null. Let's see what it can, the operator can be unconditionally invoked. Okay, because it thinks, yeah, e could be null basically in here, okay? So we could say if e is not null and e more than 10. So this is how you could actually write your own function inside this compact map functionality. I'm going off the tangent in here, but really you'll see soon how we're going to use this compact map functionality inside our homepage, okay? So what we're going to do in here, we're going to remove everything inside our homepage that we written in the previous example, except for our scaffold, okay? So I'm going to remove this body and every code inside it like this, okay? So this is how we have to have it. A homepage that's a hook widget with a scaffold and an app bar, and then we have our little compact map function on top, okay? Let's go ahead then and define the URL that we're going to use for our image. So I have a URL ready in here. Let's just paste it. It's a bit.ly URL, which is a short version of a longer URL. And this image kind of looks like this. So it's a simple image, okay? And its URL is this one. You can just find any image on the internet and just get a bit.ly link to it, or not even. Just put the entire link in there. I made this link bit.ly simply because it's just so much more. It's just so much easier to look at. It's such a short URL than having a huge URL in your application, in my opinion, at least. So what we're going to do in here is going to use something called use future. This use future is a new or it's a new hook that you haven't used before, but I'm going to show you in this chapter how to use future in order to make your futures a lot more digestible using hooks, okay? So what we're going to do in here, we're going to go first grab this image. So let's go and in here, inside our build function, let's go ahead and use network asset bundle like this. And in this network asset bundle, we need to pass a URI, as you can see in here. We're going to say URI parse our URL, just like that, okay? And then what we're going to do is to load this. So we're going to say load URL. And when we get the data in here, we're just going to say then data. We're going to say data buffer to or as uint8, I believe, list. Okay, and then we're going to create an image out of this. So we're going to say data image dot memory, image capital I memory from that data, just like that. So if I say final foo, if I can type final, you can see now the data type of this foo is actually a future of image. So it's going to load an image dynamically for us in a future and then give us that image back. Okay, so instead of just saying image.network, which does all of this for you, but I'm just trying to explain to you how futures work with use future hook in Flutter Hook. Okay, so what we're going to do in here is to actually put this code inside something called use future. Okay, So let's go ahead and say that this whole code should be inside a use future. So say final image is use future. And let's have a look at the code for use future, which is a hook. And you can see it says, okay, give me a future. Then we say, okay, here's your future, just like that. Okay. And now you can see image is an async snapshot of that image. All right. So let's just keep on holding on to that image for now. So let's go ahead then inside this, the body in here, right? Let's go ahead and say body. Then we're going to have our image. So let's just say column, for instance, and its children are empty for now. But what we're going to do in here is to say image, since it's an async snapshot, has data. Then we're going to say image.data, otherwise null. Okay. And in here, we're just going to do a compact map at the end of this. So, and then we're going to make this a list as well, to list, because column needs a list. So I'm going to put some commas in here to make the code a little bit more readable, like this. Okay. And a comma there. All right. So let's have a look at the code in here. And this is what I wanted to show you. You can see how it looks on the screen. What is happening in here is that this flickering is, you can see the flickering probably in the video as well. So I'm going to remove this from the screen so you don't get bothered by the flickering. And then while that is happening, I'm going to explain to you what is actually causing this problem. So as you know, we're using this future as an async snapshot, and it's returning that future for us, and then it's setting the image on the screen. However, when that happens, it's calling the build function again in order to be able to display that image. But calling this build function again is triggering this use future again. So every time the image is fully loaded, it's trying to load the image again. So it goes into this loop. It has no way of knowing whether this image has been downloaded before and how to hold on to it. So this is a little bit of a problem because use future doesn't hold on to any state. It simply creates the future for you and it lets you consume that. So what we need is to kind of say, okay, when you've downloaded this image, hold on to it, create some sort of a state so that we know you don't have to basically create this future again. And for that, there's a hook called useMemoized. And useMemoized is kind of like, as the documentation for useMemoized says, as you'll soon see, it creates a caching mechanism for complex objects, because this is kind of a complex object. It's an image. It's a whole class. If you go into image, it is a complex. It's a stateful widget. So somehow we need to cache it. Okay. And for that, we're going to use useMemoized. So as you can see in here, useMemoized allows caching of complex objects. And if it has a cached version of that complex object from before, it will return that. Otherwise, it will kick off that object's future, in this case, our image, and then it will hold on to that state afterwards, okay? So let's go ahead and create that future with useMemoized. So here's our image. So I'm gonna remove that in here and remove the semicolon in here as well. So, and we're gonna use a new hook called useMemoized. Okay, like that. And you can see it returns, it requires a function that returns something. And this function doesn't take any values in. Okay, so what we're going to do is to say, here's no values coming in. And the return of this is actually the future itself. Okay, so let's just say future, useMemoized. And as you can see, we're actually creating the memoiz itself here. Okay, so what we need to do now is to actually consume this future. Okay, you see this future now is an async snapshot of image, but we actually need to consume it. Okay, so let's go ahead in here and say final snapshot is use future, and we're gonna say future like this. Okay, let's see, you actually in here we should say no use future anymore. So we have to remove this use future from here. So let's go ahead and I'm going to get rid of that, remove this use future from here, and instead have the useMemoized only. And you can see now the return of this is actually a future of image, okay? It's not an async snapshot. So the useMemoized itself is creating the future and holding onto it as a complex object, and then a snapshot is consuming that, okay? So what we're going to do then is to use that snapshot inside our column. So here is, we have the children. Let's just go ahead, children, remove that. I'm going to remove this. Actually, let's keep the compact map in here. And what we're going to do to say snapshot.data. And you can see it's an optional image. And that's great because we have this compact map, which is going to remove null values from the children of this column. And then we're going to save that. So let me bring up the, let's bring up the simulator, and I'll bring it here. And you'll now see that no image is being re-downloaded on the screen. So have a look at this code one more time. Use memoized caches a complex object. Okay, this is a future of an image. Okay, future image that is being actually cached inside this. You can see future image. Okay, so this is caching it. Okay, so it doesn't re-download it. After you have the future, you have to consume it. And that's why we have use future in here, okay? Which gives us the snapshot. Since the future is reused, meaning that it is cached, is not going to be re-downloaded or resubscribed to every time the build function is called, meaning that you can safely add it to your column in here like snapshot data and then consume it without a problem. So great. Now we've used use memoized and use future as well. And hopefully you are getting a hang of how Flutter hooks actually work. So let's go ahead in here and commit our code. I'm going to go and say, let's see. Are these errors happening right now? Actually, it seems like these errors are actually null check operator used on a null value. So this is really not good. And this is probably something to do with our compact map, to be honest with you. So let's go ahead and see what could be causing that value. And and as we can see in here, E not null transform. Okay, and we're just using compact map. So what could be causing this? Let me just do a hot restart of the application. It could just be old data, to be honest with you. And it was. So I think I just needed to do a hot restart for the changes to compact map to take effect. So I don't think we have to worry about that right now. So as is traditional, let's go ahead and add all of these to the staging area and commit our code as step 3. Great. And then I'm going to tag the code as step 3 as well. Okay. So git log, we have step 3, step 2, and then step 1. And then I'm going to say git tag, and we have step 1, 2, and 3. I don't think you can actually see it, but I'll bring up Visual Studio Code in here so you can see 1, 2, 3. Okay, perfect. So that was our third example. And now we can finally move on to the fourth example in this chapter. Okay, then. So let's go ahead and move on to the next example. And in this example, we're going to use a new hook that is going to allow us to listen for changes in a change notifier and a value notifier. And this one is going to be a simple countdown. So we're going to have a value notifier that holds onto an integer. So the logic will be inside a class we're going to call countdown. And the countdown class expects an integer value. And let's say you say a countdown of 20. And what this countdown value notifier is going to do is going to start from 20, and it's just going to count down until it reaches 0. And then it's going to stop right there. So this is going to be our value notifier, and then we're going to use a new hook in this example called use listenable. Remember, value notifiers and change notifiers, as I've explained in the previous chapters where we talked about them, they're listenables. And there is a great hook in Flutter hooks called use listenable, which does exactly as its name indicates. It consumes a listenable, and it calls your build function whenever that listenable's value changes. Okay. But remember, we're going to have to use the use memoized function as well, because if you don't use memoized and create your listenable inside use memoized, then every time the build function of your Flutter hook or your HookWidget's build function gets called, that listenable will be created over and over again. So every time it's going to be creating a new instance of that countdown class. In order not to do that and prevent doing that, we're going to cache that instance of our countdown using a memoized, and then we're gonna use listenable hook in order to listen for changes inside that value notifier. I know these are just a lot of big words, maybe complicated words, but don't worry. I mean, the code itself is very simple, as you'll soon see. So let's go ahead and create a countdown notifier, and let's clean up maybe some stuff in here, or not. Actually, let's not do that for now. Maybe remove this URL from here. Okay, and I'm gonna remove the snapshot stuff from here, and perhaps remove the body as well. Okay, so what we're gonna do is to start using or start writing our countdown class in here. I'm gonna do a hot restart. So our simulator is here. There's no image displayed on the screen. And let's go ahead and write our class countdown, okay? And this class is actually, it extends value notifier of type integer, okay? So, and you can see in here, we actually have to pass a parameter to it. So what we're gonna do is to create the, we're gonna create the constructor of this class. But before doing that, since in this class we're going to listen to a stream that starts from the given value until it reaches 0, we need a stream subscription. So I'm going to say late stream subscription, and I'm just going to call it sub. Okay, and soon we're going to address this problem with the calling the super class. So let's go ahead and create a constructor for our class. I'm just going to say count down, and it's going to have a required integer parameter called from, and we're just going to say super from. Okay, so we're calling super in there. And in here, we're going to set up the subscription. So let's go ahead and take care of this, the creation of the subscription. So let's just say sub is stream dot periodic, and a constant duration of seconds 1, as you can see in here. Okay, and every time we get a value, we're just going to say, okay, from minus value. Okay, just like that. So this from that was given to us, where the first time our stream ticks is going to give us the value of 0, 1, 2, 3, meaning that if we minus or subtract those values from, then we're going to go, for instance, from 20 minus 0, which is 20. Next tick, the value will be 1, 20 minus 1, 19. Third time value is going to be 2, 20 minus 2, 18. So we're literally going from 20 down. Okay, so let's go ahead, and in here I'm just going to say v, which is that value. Okay, and then what we're going to do in this is the periodic stream, but we're going to say take while, okay, our value should be more than or equal to 0. And then we're going to actually listen to those changes. You can see this event coming in here. And then we're going to update this value to this event. Okay. Well, you can see it's saying this value, and that's simply because I want this actually to be called value and here to not do shadowing. Okay. So that's our code, really. This is the subscription. As you can see, we're setting up subscription to a stream that triggers values periodically. Okay. And then it takes the values while those values are more or equal to 0, more than or equal to 0, meaning that as soon as we hit 0, we take that value 0, and then the stream subscription stops, or the stream itself stops. Okay, this is not the subscription. What we need to do then is to get rid of this stream subscription when our countdown class is disposed of. So let's go ahead and override the dispose function in here. So we're just going to say dispose, okay, and then get rid of our subscription in here. So we cancel our subscription. So what we need then is inside this home page, which is a hook widget, is to create an instance of our countdown and also hold on to it, meaning that we don't want this instance to be created again and again every time the build function gets called. So we just want to hold on to it. Remember from the previous example when we talked about holding on to complex objects, caching complex objects, that was with use memoized. That's exactly what we're going to do in here. Okay, so let's just say final countdown. Something like this. Countdown is use memoized. Okay. And what this guy is just going to do is to create a countdown that goes from the value from 20. Okay. And if you look at this countdown now, it is actually an instance of countdown. So it's not a future, it's not a stream. All you're doing really is just to say, I want to create something, hold on to it. That's it. That's what use memoirs does. Okay. So nothing magical really. It's just caching a complex object. All right. So what we then need to do is actually listen for changes to this countdown. Remember, countdown is a value notifier that holds onto an integer. So this new hook that we're using in here is, let's just say notifier, use listenable. This new hook is called use listenable, and we're going to listen for changes to this countdown. So now that we have that, we're going to go ahead and change the body of our scaffold in here, and we're just going to say we use text of notifier dot value, which is an integer, and then we're going to make it a string. Okay, as simple as that. So there's nothing really magical happening in here, and a column there as well. So let's have a look at how this actually looks on the screen. So I'm gonna hot restart and then watch the changes. You can see in here, we start with 20, 18, and it goes on and on until it hits 0, which is our take while kicking in and saying that as soon as you reach 0, we don't want to continue anymore. So that's use listenable. All it does is that it creates, you see this value for you, which is, wait a minute, this notifier in here, it's our countdown basically, and it gives us the value right there. So use listen. You may be wondering, I mean, this countdown you can see in here is a countdown, and your notifier is also a countdown. So you're probably wondering, like, okay, but wait a minute, if countdown is a countdown, why do we even need the notifier? Remember, use memoized cached that countdown. It doesn't call the build function again every time the countdown's value changes. All use memoirs is doing is just caching countdown. That's why it gives you the countdown back. However, use listenable basically calls the build function every time this countdown calls is a notify listeners function. Every time that countdown, which is a value listenable or a value notifier, changes its value, this use listenable calls the build function again. So let's go ahead and put a print in here. Print hello, okay, just like that. And if you see in here, this hello is being printed here to the screen, meaning that we did come to this build function. And this text, which is dependent on that value, is being rebuilt over and over again, okay? So that's really the state that we have to leave this section of this chapter. It's not more complicated than that. It's just using use listenable. I just want you to see how that works as well. So let's go ahead and commit this code that we've written for this section, and git add all, and then git commit. And this is going to be our step 4. And let's tag it as well as step 4, just like that. And after this is actually time to have a look at another example. As I mentioned in the beginning of this chapter, we're going to create 8 separate examples in this chapter to demonstrate the use of Flutter hooks. So what we're going to do in this chapter is actually going to be, in this section of this chapter, is to display an interesting effect that you may not be familiar with from before. And we're going to do all of that with Flutter hooks. It's very difficult to explain what we're gonna achieve in this section of the chapter without actually showing you the results that we're gonna get. So here's the code that I've already written before I start recording this, and this is what we're gonna achieve in this section of this chapter. As you can see, we have an image in here and also a list view. What we're going to do is to tie this list view's scrolling events to this image's height, meaning that as you start scrolling, we are going to not only completely hide that list and hide that image on top, but we're also going to change its height. As you can see, there is an opacity being applied to that image. So the more you scroll down, the more visible that image becomes. So when you actually come to this list view's top, the image is completely visible, and its opacity is at 1 or 100%. So this is something you can also kind of achieve with slivers in Flutter, but we're going to try to do that with Flutter hooks in this chapter. So this application is going to have some states, but as you've seen before, we're not going to have any stateful widgets in order to achieve this effect. So now that you've seen how this actually looks like, let's go ahead and first define the URL for our image. So let's go ahead and remove all this code that we have in here. So like that. And also going to remove the notifier, and also I'm going to remove the body in here. Okay. So what we need is the URL of our image. So I'm just going to paste that URL in here, and we have some problem with hot reloading simply because our application is invisible on the screen right now. So hot reload working. Now let's put our image URL in here. It's a shortened bit.ly URL, which leads simply to this image on smh.com Australia. So it's a simple image. You can put any other image that you wish to. So what we also need is the height of that image that needs to be displayed on the screen. So let's go ahead and say const image height is 300. Just like this. Okay. So what we need is in this application is we're going to take like the scrolling offset of our list view. And as that changes, we're going to resize our image view's height. So we kind of need normalization of double values in here. And if you're not familiar with what normalization means, is usually normalization when you're talking about floating point numbers is that you take a value between X and Y and you reduce that value's range to a value between 0 and 1 inclusive. So let's say you have a value between 0 to 300 and you normalize it to 0 to 1. Then your resulting value will actually be 1 because 300 is the uppermost range of your value. Or if you have a value between 0 and 600 and your current value is 300, if you normalize that value to a range of 0 to 1, the result actually will be 0.5, meaning half the range, since 300 is it's literally in the middle range of 0 to 600. So that process is called normalization, and there is lots of documentation on the internet available on what normalization actually means, and there is a good Wikipedia site for that as well. So what we need in here is a simple normalize extension, and we're gonna write this on num. Num is a class that is an abstract class, I believe, that the value of double actually adheres to in Dart. So let's go ahead and write our normalization extension on num. So I'm gonna just copy that code right here and paste it right here, just like that. Okay, and then what we're gonna do is to actually grab the functions, actually write the functions definition. So we're gonna say this function returns a number as well. It's called normalized, okay? And it has 4 parameters in here, which the first one is self range min, meaning that the current value's actual range, and self range max. And optionally, we also need 2 parameters in here. And what we're going to do is to call them normalize range min and normalize range max, meaning that they usually like the value that you actually want to transfer your current value to. Okay, so let's call this normalized range min, usually 0, and normalize range max, which is 1. Okay. So then we're going to actually write the functions body for this. So here, I mean, the way that we've defined this function, you have the ability to pass any other value in here instead of normalizing your value to a destination of 0 to 1. You can normalize it to a value of, for instance, 0 to 100. But we're usually going to do 0 to 1 because that's usually what normalization actually means. So I'm not actually going to write the function body. I'm going to copy and paste it in here. And this is like the typical formula for normalizing a value in the range of X to Y to another value of, for instance, T to E, which is this to this. So this is the formula for doing that. And you can have a look at this code. You can pause it in here, and you actually can do some experiments I did on paper as well, just to get the point of how this actually works. So you can try to, like, in your head also calculate, okay, if I have a value that can fall anywhere between 0 to 100, but its current value is 50, and I want to normalize that to a value between 0 to 1, how does this formula actually help? So I suggest that you pause the video now and maybe just do some calculation also on a piece of paper so you get this idea better. So we've already cleaned up the code in our homepage, so we don't have to do that. But if you haven't done the cleanup, just go ahead and please remove almost everything except for your scaffold and your app bar. So we need two animation controllers in here, as you saw in the actual example. I'll bring the simulator up. So it looked like this. You can see that we have an animation controller that changes the height of this image. And then we have another one that changes the opacity. So we have two animation controllers that we're going to use two hooks for that. Okay. So let's go ahead and write the opacities animation controller. So let's just say in the build function, we have a final opacity is a new hook called use animation controller. Okay. So this is very cool because if you had to do this on your own using, for instance, a StatefulWidget, then you have to conform to specific ticker providers. You'd have to create your animation controller, dispose of it. There's a lot of work to do manually if you weren't using hooks. But in here, you literally just created an animation controller without having to conform to any mix-ins. You didn't have to dispose of anything. It's just all done for you. So let's go ahead in here, and what we're going to do is to say this duration is just 1 second, because remember, these durations mean nothing in our example because we're not actually kicking off an animation. We're simply using an animation controller to hold on to the opacity and the height. Okay. So these animation controllers are really not going to kick off any animation except they're holding on to a double value. Okay. So let's just pass any duration in here. We're just going to say const duration seconds 1. Okay. And the initial value, so the opacity initially is 1. Upper bound is also 1. It can go up to the maximum 1. And its lower bound is 0. So you may want to change the positioning of these two parameters. Okay. So lower bound 0 and upper bound 1. It can't be more visible than having the opacity of 1. Okay. So that's our opacity. You also need a size animation in here. So I'm not going to write that code again. What I'm going to do is I'm just going to paste it in here. It's very similar to what we did up here for opacity. As you can see, we have the size, and the size also has the exact same values as we have here. Let's also move these parameters so they're more in line. So it's the exact same thing. We're just creating two animation controllers. Okay. So what we need also in here is we need to take care of the scrolling event. So if you go back to our demo in here, we need to hook ourselves into this list views scrolling events. And for that, we need a scroll controller. So if you didn't have Flutter hooks, you would have to go and create the scroll controller manually and then hook into various events, add listeners, etc. But with Flutter hooks, we can actually say use scroll controller. So let's go ahead and say final controller is use scroll controller, just like that. And now all of a sudden we have a scroll controller that we can assign to our list view in here. Okay. So what we need to do now is to start listening for our scroll controller's events. So what we need is to basically somehow hook ourselves into this controller, and whenever its events change, then we need to do something. So what we were going to do in here is just going to say use effect, and we've seen use effect before. So in this use effect, what we're going to do is to go ahead and create a function in here, just like that. And there we're going to add a listener to our controller. Okay. So let's just go ahead and add a listener to this controller. So let's say add listener right here. Okay. Just like that. And we're going to write the code for that. And don't forget the code that you have for your controller key in here, just like that. So what this is going to create for us is simply a function that gets called only once as long as this key doesn't change. And remember, this is the key parameter in here. As long as the controller hasn't changed, this function is called only once. And in here, then we're setting up basically our listening events on these on the scroll controller, which is this object right here, this controller. So what we need to do in here to grab the opacity and assign it to a variable. So let's go ahead in here in this function of our add listener, say final new opacity. We're just going to need the maximum value. And this max is actually in Dart math. So I'm going to import that in here. So we can use max now. And I'm just going to say image height, okay, minus the controller's offset, and the maximum value between that and 0. Okay, so this is going to give us the opacity. And we're going to take the normalized value of this, or let's just say normalized is equal to new opacity dot normalize. We're just going to normalize it like that and say this value, incoming value, is between 0 and the image height. Okay, but we want to have a value between 0 and 1, which is the opacity that we're going to assign to our opacity animation controller. So after normalizing that, we're also, as you can see, this is now going to be a number, but we want a double value. Sorry, let's just say 2 double, just like that right there. Excuse me. So now we're normalizing the opacity, and then what we need to do is to set that value on our controller. So let's go ahead and say opacity.value. Remember, opacity is actually our opacity animation controller that we're setting its value to normalized, just like that, and that is a double value. So, and then we also gonna say size.value. And we don't have to do this 2 double business because we've already done the 2 double. So don't mind the caption at the bottom of the screen. So we're going to size value is normalized like that. Okay. So now we've set that. And remember, then this function also usually needs to return a value. If you look at use effect, actually it says void function effect in here. Wait a minute. Use effect. If you go in here, it needs to optionally return a dispose. So in here, we're returning null just to indicate that we're not actually, you see, it says this function has a null of a return value. That's why this return null is there. We're going to add now a column to this scaffold right here as its body. So let's just say column. And then for its children, it's just going to be an empty list in here. Okay. Perfect. So let me bring the application to the foreground so that we don't have problem doing a hot reload. So what we're going to do then is to add an image, a list view in here. So in that list view, we're just going to populate it with 100 list tiles and put it inside expanded. Okay, so let's go ahead in here and say list view dot builder, and we're going to say item count is 100, and then we're going to say item builder, and this is a function in here. Visual Studio Code is not really helping at the moment. Just going to say context and index, okay? And in here, I'm going to say return list tile, and its title is just going to be a text, and let's say person, other index +1, because index are 0 based, okay? So we're returning the list tile. Inside in here, we have the text as well. And let's put this list view also inside and expanded. So I'm going to say wrap with widget expanded. So it can take all the available height on the screen. So let's have a look at the code that we have now. You can see that we have our list view, but we don't have the image yet. And we're going to add the image now to the top of our column. And so it's going to be a box fits of cover. And let's just grab that and place it as the child. It's one of the children in here, just like that. So I'm just going to paste it right there. So now we have the image view, and we have the image, and we have the list view, but there's no opacity or anything applied to that image right now. So the first thing we need to do is to wrap this image inside a fade transition. This fade transition is going to consume our opacity controller. Okay, so let's go ahead in here. I'm just going to say this image is going to be wrapped with a widget. And this is going to be a fade transition. And its opacity, you can see, is an animation of type double. So let me remove this and put it back in here so you see it's an animation of double. And for this, we have opacity. Okay. Now that we've done that, we also have to wrap our fade transition inside a size transition, because the fade transition is going to take care of changing the opacity of the image view. However, there's nothing changing the height of that image. For that, we need our new size transition. So I'm just going to go in here and say, I'm going to wrap this with a widget called size transition, like this. And its size, let's see, size factor. So this size factor is going to be the actual size animation controller that we created, okay? And its axis is going to be vertical. So it's an axis of vertical. And also is size factor is going to be, so let me bring that up. So axis alignment here. So we have to set the axis alignment also to the value of -1, double, like that. And we've set the size of the transition already. So what we can do now is actually have a look at this in action. So this is our application now. And let me just do a hot restart. And I can see the reason that we're not seeing any results in here is simply because this list view that we created in here is not really consuming our controller, which is the scroll controller. So let's go ahead in the list view builder, say the controller is the controller, as you can see in here, which is this use scroll controller that we created previously, and hot reload. Now you can see as we scroll, then the image is changing its opacity and also the height. And all of that really is happening inside this use effect. So as long as this controller, which is a scroll controller, isn't changing, this function is only called once, meaning that it's adding a listener only once to that scroll controller. Well, fantastic. That's really all we have to do. So let's just go ahead and commit this code as well. And I'm going to bring up the terminal, the built-in terminal. We just do the code and say git add all, git commit, and we're going to call this step 5, and git tag also as step 5. Okay, fantastic. So that was the 5th example of this chapter. Okay, then. In the next example that we will look at, we're going to use a new hook, and that new hook is called use StreamController. And this StreamController is going to allow us to actually create some really fun application. As you can see in here, this is what we're going to achieve in this example. And it is simply drawing an image in the center of the screen. And every tap, we're just going to rotate this image on the screen. So nothing really fancy. It's just using a StreamController that's holding onto the rotation value of this image. And every time you tap on that image, we're changing the value, and we're actually adding some degrees of rotation to that StreamController. Once that the stream inside the StreamController's value changes, we're redrawing our HookWidget with this new image that is rotated according to the angle defined inside the StreamController's stream. So this is all just fancy word of saying we're rotating an image. So let's go ahead and clean up the code inside our application. So we're not going to remove the URL of the image, but we're going to remove pretty much everything else in our application. So let's go ahead, and I'm going to do that. I'm going to keep the scaffold, and I'm going to remove the entire body in here, just like that. So that's gone. And let's just go ahead and I'm not sure if actually we're gonna need the normalization value in here. I'm gonna search in my code in here. I can see we don't need the normalize, to be honest with you. So let's just go ahead and remove the normalization code as well. So the image height we don't need really, I think. So we're just gonna keep the URL of our image and pretty much just remove everything else, okay? So we want an image that rotates on every tap. For this, we'll create a stream controller that holds onto our rotation. So as I mentioned, the stream controller has a stream, and the stream itself holds onto a degree, which is our image's rotation value. So let's go ahead and define our stream controller. So in this build function that we have right here, we're just going to go ahead and create our stream controller. So let's just go ahead and say late final in here, late final stream controller of double, and we're just going to call it controller. So we're going to create this controller soon, okay? So we need to set an initial value for this stream controller, and we're going to do that inside the listen function of the creation of the stream controller. Okay, so let's go ahead and start writing that functionality. So then we're going to say controller is equal to use stream controller, which is this new hook that we're working with in this section of the chapter, and this is a double. And in here, then you have this function, this property or parameter called onListen. And while this listen then is called, inside this listen, we're going to set the initial value of our controller. So we're going to say controller sync add 0. So this is the default rotation value of our controller. So let's go ahead and add the image as the body of our scaffold. So in here, I'm just going to say body image network, and we're just going to say URL, which is that URL that we had from before. So if I run our application right now, let's go back here. You can see the image is displayed right there. So let's go ahead and wrap this inside a center. So to put it in the middle of the screen, wrap with center like that. And I'm going to close that with a colon. As you can see, the image is now displayed in the center of the screen. So what we need is a rotation transition. We need to actually put this center tag with this image inside a rotation transition. Okay, so let's go ahead and say that this center is inside a rotation transition. So wrap it with a widget, and we're going to say rotation transition. Okay. And this rotation transition for its turns is, you see, it needs an animation of double, but we are going to use an always stopped animation. And you can see this always stopped animation requires the actual rotation value. And we need to then grab this rotation value from our stream. So how do we do that? At the moment, let's just say the value of 0. Okay. And I think it's actually called turns, not turn. Okay, so we're just going to say always stop animation. And for that, we need the rotation. As you can see at the bottom of the screen, I've mentioned that we need the actual rotation, but we don't have that rotation yet. Okay, so let's go ahead and use our stream builder to grab the rotation. So before we do that, we're going to put this rotation transition inside a gesture detector. And this gesture detector is going to allow the user to tap on this image. And every tap is then going to change that StreamController's value. So let's go ahead and say a gesture detector, wrap it with widget, gesture detector. Okay. And in here, we're going to say on tap, I believe. Just like that. It's an empty function for now. And then we're going to say controller dot sync add. And we kind of need to grab the rotation in here. So let's just say rotation plus 10 degrees. Okay. But remember, we don't have the rotation yet. So in here also, we're going to put the rotation. But remember, we don't have the current rotation. We're going to get that soon. Okay. So let's put this rotation transition that we created in here and this gesture detector, to be honest with you, totally inside a stream builder, because we have our stream controller in here, but we're not consuming it with a stream builder. So let's go ahead in here and say gesture detector, and everything inside the body of the scaffold is inside the stream builder. And it's a stream builder of double. And the stream itself, really, it's coming from our controller. So let's just say then the stream itself is coming from the controller's stream, just like that. And then what we need to do in here, you can see that we have the snapshot, and this should be a snapshot of double. And let's just go ahead and say final rotation is snapshot data, or the value of 0. But if we're doing things right, really, we have to look at also, what is it complaining about? Rotation, argument of a constant. Okay, this can't be a constant anymore. But if you're doing things right with a stream builder, you don't want to just use the data like this. You want to first check if there is data. So let's say if snapshot.has data, actually, if snapshot doesn't have data, then we're going to return a circular progress indicator. Otherwise, if we do have data, then let's put all this code inside that. So the gesture detector and everything else. Let's see. I'll return the gesture detector like that, and then we're going to put that inside the else statement. So it's very simple. If we don't have data, we return a progress indicator. If we do have data, then we're going to return the rest. And you can see that we're reading the rotation from our snapshot data, or we take the value of 0. Okay. So let's go ahead and see this in action. So I'm just going to do a hot restart just to be sure. And here's our image. And now I'm just going to tap on this guy, and I can see nothing is really happening. So let's see why that would be. So I'm going to do a hot restart in here. Look at the debug console, and let's see if we are gesture detector on tap, rotation plus 10. That to me looks fine, to be honest with you. And in here, Oh, because we have rotation in here, we have to say we divide this by 360 because otherwise we're not seeing anything happen on the screen. So I'm going to do a hot restart. So sorry about that. We just, because this is in radians, but our rotation value is actually in degrees. So now we can see that the value, yeah, the image is rotating across its center. So this was a very simple usage of a new hook, which creates a stream controller for you. So just because you have a stream in your application, you don't have to go and create a stateful widget. This demonstrates the use of stream controllers, and it consumes or uses the use stream controller hook. Okay. So let's go ahead and commit and tag this code as well. So this is going to be the 6th example in this chapter. So let's go to terminal, and then I'm just going to say git status, git add all, okay, and then git commit, and this is step 6. And let's tag it as step 6 as well. So if you have a look at all our tags, then we have 1, 2, 3, 4, 5, 6, and all our commits are also there. So fantastic. So that's really all we have to do for this particular example. Well, that was great. We've achieved quite a lot in this chapter already. We've done 6 separate examples, each of which explains a one or multiple hooks in Flutter Hooks. For this next example, we're going to do something a little bit more complicated. And we will talk about reducers. And this is a pattern that's, if you're familiar with Redux, you're probably familiar also with reducers. But if you're not, I'll explain how this actually works, just very shallow for now. I'm not going to go into the details of Redux, but basically the way it works is that you have a state and you have actions. And the state of course explains the state of your application, or for instance a specific screen, whereas action could be user input. A reducer is a function that takes a current state and the current action being performed by, for instance, the user, and returns a new action. It returns a new state. And the state will then become the current state. So what we're going to develop in this chapter is going to look, in this section is going to look like this. So we have our normal image in here, and then we have the current state, which is the image, which is rotated at the moment, for instance, with 0 degrees. And then you can say rotate left, rotate right, less visible, and more visible. So this application, it has some state. However, it is not going to actually be a stateful widget, as you'd imagine with Flutter Hooks. So what we're going to do is to create, use our use reducer hook, as you'll soon see. Flutter Hooks allows you to hook into, maybe hook into wasn't the best choice of word here, but hook into hooks and hook into your reducers as well. So just think that reducer is something that takes the current state and a provided action and produces a new state, okay? So these 4 buttons that we're going to have on our user interface are just going to be rotate left, right, and less visible and more visible. And less visible is going to take you to almost hidden opacity, and then more visible is going to take the opacity up onto up to the value of 1. So what we're going to do in here is go ahead and first off clean up all the code that we have in our application in here. So I'm going to go back to our app in here, which is the current application. And then I'm going to leave the URL in there, and let's just remove almost everything from our build function here. And let's also remove the body in here as well, up to and including the stream builder. Then let's just make sure that we don't have anything that's lying around. Okay, that's great. So let's go ahead and first, excuse me, define our actions. As you saw, we have 4 actions by those buttons. So they're going to be rotate left, rotate right, and then increase alpha and decrease alpha. So let's go ahead and define those. So we're going to say an enumeration of actions: rotate left, rotate right, more visible, and less visible. Okay, just like that. So if we put a comma there, so yeah. So these are our actions. These are what the buttons are going to provide to the current state, or to our reducer, basically to produce a new state, okay? And what we're going to do is to create a state, the actual state that our application currently has. So let's go ahead and define an immutable class for this. We're going to call it immutable class state, okay? And we're going to have a few properties in here. Actually, we're going to have a couple properties, so just two properties. So first of all is the rotation angle of that image expressed as degrees. So let's just say final double rotation degrees. And then we're also going to define the alpha, the current alpha value, okay? Just like that, alpha. And we're going to create the constructor for this class, just like this. I'm just going to get help from Visual Studio Code to do this as a constant in here. And let's just say required like this, and put a comma here to get the formatting done correctly as well. Okay, so to begin with, we kind of need this class to have like some sort of a 0 state. So the image is fully visible, and also the rotation and angle in degrees is 0. So let's go ahead and define an initializer here and call it const state 0, in which the rotation degree is 0 and the alpha is actually 1. So this is our initial state, so to say. Then what we're going to do is we're going to hook these. I mean, we want these buttons to produce a new states in our reducer, but we also need some sort of helper functions in this code to produce those states for us. So given the button press of rotate right, we want to get the current rotation degree and add, for instance, 10 degrees to it, or rotate left would decrease that, for instance. Okay. So let's go ahead and define some of these functions, okay? So we're going to define a new function in here called state, and that's just going to say rotate right, okay? And in here, you can see this is just a function. This is an actual function on the current instance of the state, okay? So it's not like any kind of a constructor. And in here, we're just going to say state rotate right here is going to return a new state in which the alpha is the current alpha and the rotation degree is the rotation degree plus 10 degrees. Okay, so that's our rotate right. Let's go ahead and copy this code and paste it down here and just say this is our rotate left. And in here, we're just going to decrease the rotation by 10 degrees. Okay. We're going to also similarly have a function for increase alpha. Okay. So let's go ahead and say increase alpha. I'm going to copy paste some code in here. I'm just going to say increase alpha. Okay. And what we're going to do in here, we're going to say the alpha value is the minimum of alpha plus 0, 1 and 1. Okay, because we don't want alpha value to go higher than 1. And minimum is included is a function in Dart Math. So let's include Dart Math also imported into our code. And then we're going to leave the rotation degree intact. This is for increasing the alpha. And let's go ahead and define the decrease alpha as well. And decrease alpha is taking the maximum of our alpha minus 0, 1 and 0. Okay, because if you go to a value less than 0, then 0 will actually be the maximum. So we're keeping the value between 0 and 1, so to say. Okay, so as I said, then we have the decrease alpha now, so you don't have to do anything special. So now that we have the actions and we have the state, we need to define a reducer function that can take the current state, then takes an action, and then produces a new state. Okay, so that's going to be our reducer. So let's go ahead and write this function right now. So I'm just going to say this function returns a new state, and we're going to call it a reducer. Okay, and what it does is that it takes a state, which is the old state, and it takes an action, an optional action, because in the beginning you won't have any action to perform. Okay, when you build your hook widgets for the first time, that's why action is optional to begin with. All right. So what we're going to do is to switch on our action in here. So if we say switch action, okay. And I'm going to get help from Visual Studio Code in here. And you can see it says case action, rotate left, more visible. However, there's a little bit of a problem in here. And that's because we're not actually handling null, as you can see in here, missing case null. So if there's no initial action being performed, you also have to handle that null value in here. Okay, so in that case, so let's just say in case of null, we return null, we return the old state. So if and we have a given state and no action is being performed, then we return the old state. Okay. However, in the case of rotate left, what we're going to do is to return the old state, rotate left, just like that. Okay. And rotate right is going to return. We also have to return, remove the break. Okay. So then let's just say return old state, rotate right, like that. And in here, we're going to say return old state, more or increase alpha, because more visible is hooked to increasing the alpha. So we can remove the break. And also in here, in less visible, we're going to say return old state, decrease alpha. Okay, so that's simply our reducer. I mean, there is not much more to our reducer at this point than just this. So it's very simple. So what we're going to do in here is to actually define our reducer as a hook, and that's going to use a new hook that you're not familiar with, and that is called use reducer. So we kind of want this use reducer then to be able to perform rebuilds of our widgets that are dependent on it, depending on the actions that are actually sent to this reducer. So let's go in here and say final store is using a use reducer. Okay. And you can see in here it says, okay, what is your reducer? And let's go in here into the use reducer function. So I'm going to go to a source code, and you can see it says it's a generic function that requires a state and an action. So let's in here say actually our use reducer has a state and action. And remember, these are the types that we've defined ourselves. They don't necessarily have to be called state and action. Okay. And the fact that they're called state and action here has absolutely nothing to do with the fact that they're called state and action in our source code. So they could be called something else. These are just generic names that are being used in the function header and the function body, whereas these are concrete types that we've implemented in our source code. Okay. So the reducer itself is going to be actually the reducer function. The initial state is just going to be a constant of state 0 because we start with that. Okay. And we also have to set the initial action. You see there's a parameter in here, and we're going to set this to null. So let's go in here and put this there and turn this into an optional action as well. So initial action is then null, meaning that initially we're not providing any action. You could say that you may have an initial action defined, like you may define it according to your needs, but in this example, we don't need that. So that's why we're actually making our action an optional in here in our use reducer, okay? So let's go ahead and display a network image in here, okay? So let's go ahead and I'm just gonna say an image in the body in here, okay? So let's go after the app bar and say body is an image network of our URL. So let's go to our application. It's displayed right here. Okay. So let's then go ahead and we're going to add this image inside a rotation transition and an opacity. Okay. So let's go ahead and say, first of all, it's inside a rotation transition. So rotation transition like that. Okay. And you can see in here, it says, okay, what are the actual turns? And that needs to be an animation, okay? So here we have really no animation to perform. So we're going to use always stopped animation in here, okay? So, and the value for this is actually going to be our stores. So we're going to read this current state from our store. So, and we call it store, yeah. So we're going to say store, and we're going to use its, let's see what it has. It has a state, and then it has the rotation degrees, and we're going to divide that by 360 degrees to get our radians. Okay, so that's really good. That's in place. And then after we have the rotation transition, we also have to put this inside an opacity widget. Okay, so opacity like this. Okay, and the opacity is going to come from our store state dot alpha. All right. So you can see initially it has the alpha of 1 and there's no rotation provided in here. However, if our initial state had those values, for instance, in here, 0, if let's say we had a rotation degree of 10 and the alpha of 0.5, and then we did a hot restart in here, you would see that there is an initial rotation and an alpha value provided there. Okay. But so just so you understand that it is the state 0 here that is being consumed and used in our application simply because we provided it as the initial state. Okay. Okay. Now that we've done that, let's go ahead and put this opacity inside a column, because inside this column, as you saw before, we're going to, let me actually bring the simulator. We're going to add some more components in here. We're going to add some buttons, text buttons. So let's go and add that opacity inside a column in here. So I'm just going to say wrap with column. Okay. And we have the children in here. And we're going to add a sized box right before opacity simply because we want to get this little spacing, as you can see in here, so that our image doesn't block our buttons while we're rotating it. Okay, so I'm going to go here. I'm going to kill this application as well so we don't see that ugly red screen. So let's go in here and add a size box in here, const size box, and its height, let's just say, is the value of 100. Okay, what is it complaining about? Yeah, that should be inside here in the children list. Okay, so you can see in here, right, so we're putting that size box right before the opacity, okay? So let's go ahead inside this children in here and add a row because we're going to add the buttons in here, okay? So it has children. We haven't provided them yet. So we're going to add 4 buttons in here, and we're going to hook their actions to the store. So let's create a text button, and we're going to say it's on pressed is an empty function right now, and its child is a const text. And let's just begin with, for instance, rotate left. So rotate left like that. And in here, we're just going to say store. But we're going to use a function called dispatch. And in here, we're going to provide an action of rotate left. That's how you communicate with your store, which you can see in here is basically of type store state action. So that's something that this use reducer provides to you. Okay, so that's our text button. I'm just going to copy that little text button and then go and paste it right here. I'm just going to say rotate right, and in here provide the action of rotate right. Okay, after that, let's go ahead and provide the decrease alpha. So I'm going to say decrease alpha, another text button, and in here we're just going to say less visible. And for the last button, we're just going to say more visible. And this is going to be increase alpha, something like that. Okay. So now we have these buttons in there, and I can see we got a little rendering problem. So let's just add, say, minus alpha in here and like plus alpha so that we have enough space on the screen. Okay. We could put it in a single child scroll view as well, but I'm just making it very simple for now. So we have those in place, and what we're going to do is to separate these buttons into their own widgets. So I'm just going to right click on this guy or just do like this. I'm just going to say extract widget, and let's call this new widget, for instance, what should we call it? Rotate left button. Let's call it rotate left. Okay. Rotate left button. So that's the first one. Then we're going to say rotate right button. And then we're going to have another one, which is extract widget. We're going to call it decrease alpha button and increase alpha button. Okay. So increase alpha button. Perfect. Okay, so now we have our 4 buttons, and we can do a hot reload to see the results on the screen is exactly the same. And the formatter and the actual, when we are actually extracting these into widgets, it's very intelligent, understands the dependencies that they're dependent on the store, and it passes that store as a parameter to them. So this is very intelligent, in my opinion, at least. So let's see this bad boy in action. So if we go in here now and just press these buttons, you see rotate left is working as expected, rotate right as well, alpha and plus alpha as well. So you were basically able to create an application that pretty much has 4 different states in here, or 2 state values, but 4 actions. And now you're using a use reducer, which creates a store object for you that holds on to the actual state. And you can dispatch values, as you can see in here. You can dispatch values to your store, send actions to them, and use state in here. Let's see. Use state will, use reducer will then call your reducer function with that action, and then it will give you the old state as well. And it says, okay, do something with this information. You have the old state, then you have the new state. What do you want to do with it? Produce a new state. Okay. So let's go ahead, now that we're done with this example as well, let's just go ahead and commit this code. So I'm just going to say git add all, excuse me. And let's just say git commit step 7. And I'm just then going to say git tag step 7 as well. Okay, so that's that part. We've seen now many hooks. I've kind of lost count for it, but it's I think it's around 10, 12 hooks we've probably seen so far. But there's one more hook that I usually use in my applications. And that is a very, very interesting hook that allows you to hook your application into the lifetime or the life cycle of your app as a whole. Meaning where, for instance, you will get notified where your application becomes inactive and active again, or resumed again. So it's very useful if you, for instance, have important information on the screen, such as, for instance, credit card information. So you can hide that information when an app goes to the background. You see, one thing that's very important in iOS, for instance, is that when you go into this mode, let me go here. You see this mode in here? These are not applications that are running at the moment. These are screenshots. So when an application goes into the background, iOS operating system quickly takes a screenshot of that running application. And then when it goes into this application switching mode, it displays that screenshot. So nothing is actually happening on the screen. Nothing is moving. Let's just say you have some important information on the screen, such as credit card information. You don't want that credit card information to be screenshot, even by iOS itself, or Android for that matter. So a good rule of thumb is, if you have important and sensitive information on the screen, you may want to hide that, or you should hopefully hide that information when your application becomes inactive. So for that, we're going to use a hook called use app lifecycle state. So I'm going to go into my example in here as well. So I'm just going to check out the code for the 8th example. And this example is actually going to be very, very, very small, to be honest with you, but still a good example to explain how lifecycle events are very useful in Flutter applications. Okay, so let's go ahead and first have a look at the source code for this lifecycle. So let's say final lifecycle, or app lifecycle state lifecycle. Let's have a look at this app lifecycle state, and as you can see, it's inside the platform dispatcher. And an application can be resumed, or inactive, paused, or detached. And there's a lot of documentation about these. So I'm not going to explain all of these at the at the moment in this chapter. Otherwise, this chapter is going to be very, very long. But there's really good documentation about these different lifecycle events or states. So I encourage you to go ahead and read those. So what we're going to do then is, when our application is paused, then we're going to hide some sensitive information from our screen without even having to do any stateful widgets. Okay. So let's clean up our code. I'm going to remove pretty much everything we've written in here. So here, and then let's remove the body in here as well. Okay. And the column. So that's gone, and remove all these button codes that were generated before, or regenerated actually. And I'm going to remove the action and the state and the reducer. So we pretty much don't need any of this code, to be honest. So I'm going to remove that as well. Perfect. Okay. So what we're going to do now is to grab a credit card information, a credit card asset. And I've already prepared that, so I don't need to go and grab that again. So what I'm going to do in here, just going to create a new folder. I'm going to call this assets. I'm going to put a card PNG file in here. Okay, so you can find any type of card image on the internet. So it doesn't necessarily have to be anything special. This one is, for instance, this image. Okay, quite high resolution as well. Then let's go into our pop spec YAML. and enable this image. Okay, so let's go into our YAML here. As you can see, there's assets, so enable that. And in here, we're just going to say assets / card.png. Okay, and it's a good idea. And as you can see, Visual Studio Code has actually recognized that image as well. So I'm going to do a hot restart just in case. Okay, then what we're going to do is to add the card to the body of our scaffold. So I'm not going to write the entire code for that, to be honest with you. That's quite boring. So I'll just say body, and then I'll paste some code in here. I'll explain what this is actually doing. It's a container with a child of an image, and this image is using that assets card PNG. And this container has a box decoration and it has a shadow. So if you have a look at it, it kind of looks just like this. So you can see there is a little shadow. And if you remove that shadow, then yeah, it's not going to look as exciting. So it's just a plain card. Okay. So we add some shadow to it so to make it, to spice it up a little bit. So let's go ahead in here and then use the app lifecycle state in here. So let's say in here, we're going to say final state. Okay. So we're going to say is using this use app lifecycle state. Okay. And now you can see the state itself is that app lifecycle state itself. So you don't actually have to do any StatefulWidget or any type of function, any callback. Now that you're using this hook, the build function of your widget, HookWidget, will be called again whenever this lifecycle state changes. Okay. So let's go ahead and wrap our container with an opacity widget in here. So let's say we wrap it with opacity because we want to change the opacity of this container when the application is not active anymore. Okay. So let's go ahead in here and then say the actual opacity, which is a value between 0 to 1 inclusive, should be, as long as the state is app lifecycle state paused, resumed, app lifecycle resumed, then we're going to say 1. Otherwise is 0. Okay, so perfect. And then let's just wrap this opacity also inside some padding like that. Okay, so let's see this also in action. Let's then send this application to the paused state, meaning I'm going to send the application kind of like to the application browser in iOS. And you can see as soon as I did that, the card was hidden. If I bring the app, the card gets displayed. But as soon as the application becomes hidden again, then the card image is gone. Meaning that if I have like this app also open and then go to the app browser in iOS, then that card image is disabled. And then it's enabled again or displayed again when you go into our application. Okay, so let's commit this code as well. And this was like the last bit of code that we were writing in this chapter. So I'm just going to say git add all, git commit, and this is step 8. And then we're going to say git tag, and then I'm going to say git tag step 8 as well. Step 8. Okay. So we've seen a lot of hooks by now. I would say about a dozen, hopefully, actually. So what you need to do really is to have a look at these hooks yourselves in the Flutter Hooks GitHub repository or even on pub dev, and try to come up with different ways that these hooks could be useful for you. In my opinion, one of the absolute most useful hooks in Flutter Hooks is use memoirs, because use memoirs can hold on to a state. As you saw before, some things, like if you had a future or something, we actually had to hold on to some sort of a state so that that future wouldn't be triggered again and again. For instance, when we looked at the downloading and displaying of a network image. So, but that's just my opinion. In my experience, I've found that hook to be one of the most important hooks. So, but go ahead. I hope that you can go and make some use cases for these different hooks and hopefully integrate them into your own project. So I really hope that you enjoyed this chapter. And this is going to be a build-up of the chapter where I'm going to talk about Riverpod. So if you've watched this chapter from beginning to end, then you're very well prepared to actually take on the chapter about Riverpod. So I hope to see you there.